We introduced Scaffold Sketch, a system that makes it possible to draw accurate 3D models in VR. People like to draw in VR because it is immersive and the output is in 3D. But it's really hard to be accurate. Previous work has already proved this. More degrees of freedom, lack of physical surface, and depth issue, these all contribute to larger errors directly drawing in VR. So how do people draw accurately in 2D? Product designers can draw very accurate sketches. When they draw with pen and paper, they will first draw construction lines, all known as scaffolds. Then they will draw the object shape on top. The scaffolds will serve as view guidance to make the shape strokes accurate. This is how industrial designers can draw an accurate trash can. There are also related works studying or utilizing this scaffold plus shape way of sketching. Can we borrow this approach directly in VR? Even with the help of scaffolds, people still cannot draw accurately. The reason is similar as before. With more degrees of freedom, it requires higher motion control. Even the scaffolds are not perfectly aligned with each other. If we could eliminate these issues, we would have a nice way to draw accurately in VR. We introduced Scaffold Sketch. A system helps people draw accurately in VR by auto-correcting scaffolds and shape strokes. The scaffolds are straight lines with special relationships, so they can snap to each other based on the endpoints, directions, and lengths. We also support tick on the scaffold lines to mark intermediate positions, as designers often do with pen and paper. Here is an example. The black lines are existing scaffold lines. When the user draws a new scaffold line, we can consider these relationships. However, relationships may conflict with each other. Previous attempts to resolve conflicts often use heuristics or don't satisfy any. We resolve with an iteratively reweighted least square scheme. The weights will be updated after each iteration. The more satisfiable constraints will be given higher weights, and the less satisfied will have smaller weights. In the end, the weights will either be infinity or zero, that is, satisfied or discarded for the constraints. The shape strokes are smooth curves or lines attached to the scaffolds, many attached to the endpoints, midpoints, or the user-marked positions, and usually tangent to those points. For the same scaffold square, different user input will be autocorrect to different results. The shape strokes are autocorrected based on the scaffolds and the user's drawing, just like how the scaffolds support shape strokes in 2D. We also support space curves as shown here. And with more tick marks as intermediate positions, the autocorrect result will also be different. Once we have the beautified scaffolds, now if the user draws a shape curve, we can find whether the curve is tangent to the intersections. Thus, we can have the curve directions and positions at those key points. The positions and directions are fixed at those points, but we can change the magnitude of the tangents. Different magnitudes of tangents will give us different curves. And our goal is to find the most smooth curve, that is, the one of minimal variation of curvature. And if the curve is not tangent to the scaffolds, we will take the directions from the original curve. Here is an example of the input scaffolds, and this is the autocorrected result. The shape strokes are based on the scaffolds. and this corresponding autocorrect result. We did a remote user study with 6 participants, all industrial designers. They used our system in 2 conditions, with and without autocorrect. They all expressed that autocorrect helped them draw more accurately, and they want to use scaffold sketch in the future. See the paper for details. Limitations and future work. We didn't consider surfacing, which is also very important. The current output is curved networks, but surfaces are often needed. Without surfacing, it's hard to draw details or shading strokes. And also, current shape strokes are guided by the scaffolds, so the user cannot draw free-form strokes. I think with all these features combined, it will make a better user experience and more vivid 3D models. In conclusion, scaffold sketch enables precise 3D curve drawing by decomposing autocorrect into scaffold and shape stages. It lets people transfer industrial design drawing skills into 3D, and it resolves conflicting constraints with an iterative reweighted scheme. Thank you.